Hello folks, good morning. It's morning here. So welcome to the today's tutorial. So in previous tutorial we have added the vehicle and it was running forward and backward, but it was not having capability to turn left and right. So today we will see how we can do that. Okay, so let's get back to the code. So go back to the BP underscore vehicle base, go to the parent class of it. So let okay, so it's here. So first thing first, we need to create a binding as we have created for the move forward. So we will just go to this function setup player input component and player input component bind axis f name move right, if I remember it correctly. We will define it if we haven't, this comma and am vehicle base, and it will be move right. Okay, so just click it, click on this icon here if your ID is this one, if you're using rider, and I will call it value. That's it, I guess. Okay, or rather what you can actually do, you can just like I won't define this under the public, like go to the private section and void, you can just manually type it move right and float value. We just have given the definition, so alt enter generate definition. So it's just a shortcut, just it gives me a little bit edge of the time. So now we should good to go. Like as soon as I will like move right, it will go to this definition. We have given the address. Okay, move right. Okay, so the next thing which we have to do, like as we have done the forward axis value, I will define the same for the right axis. So I will just right axis value. If you haven't seen my previous tutorial, I will highly encourage you to go through that tutorial. So like you can follow it along. So right axis value is equals to value. It's kind of same as before, but the issue is we have to rotate the vehicle and it is the physics. So I will give you a hint, like you can pause the video, you can try on your own. What you can do, like we have added the active forward vector, you just need to add the torque, that's it. If you have applied it correctly, it will be awesome. Okay, so we will go to update vehicle force, and what we will actually do, we will calculate the linear velocity. So it is f vector world, just a second, world linear velocity is equals to vehicle mesh body mesh component, I think this is the one if I'm not wrong, yes, dot get physics linear velocity, yes, and this is it. So it will give us the world linear velocity, just a second, it will be I. Okay, now we have to calculate the local linear velocity. So what we will just use the transformation f vector local linear velocity is equals to so it is under the Kismet math library, double colon and inverse direction, and first I have to give the transform which I will use to calculate the inverse. So I will use the bodies mesh and get transform, get component transform, I will use component transform comma world linear velocity. So what it will do, it will use this matrix, this transform, to transform the world linear velocity to the local linear velocity. So we have changed the world axis to the local axis. So it is kind of easy to deal with the local linear axis, that's it. So as soon as we are done after this, I will just okay, we need one more thing, like how much we want to like rotate our wheels. So I will go to the public here. I will just copy paste the U property and float right, sorry, it will be max steering angle. And for the initial I can like give 30, but we can manipulate in blueprint also. So let's go back, and so float current steering angle is equals to U Kismet Math Library map range clamped right axis value comma -1. Just give me a second, I will explain you everything. -1 to 1 steering max steering angle into -1 comma max steering angle. That's it. Okay, so what we are doing here, the thing is, when we will press the move right button, like left and right, A, D, or the left arrow or the right arrow, what it will do, it will give the value from -1 to 1 and will save it in axis value, correct? What we are doing using the map range clamped, we are mapping this to the max steering angle, correct? And we are just multiplying -1. Let's imagine if we want to map -1 to 1 to -30 to 30, so it is like that. And now we will rotate. So if, and I will only rotate if our speed is kind of positive. So world linear velocity dot size squared is equals to 1. So you must be thinking like, why I haven't just put the size, because it will save me some mathematical calculation, like because we are already running in Take, so I will minimize the calculations as possible. Okay, so what I will do, I will like mesh body mesh C, add torque in degrees, and I just want to rotate it along the z-axis. So f vector 0 comma 0 comma current steering angle, and it will be named none, and it will be true. I want the b acceleration change to be true, so it will just rotate the vehicle. So if there is one issue using this implementation, but let's check if we are running fine or not. Let my ID load my Unreal. Okay, it's loaded. Go back to the first we will create the binding. So go to the project setting, go to the input. Do we have move right? Yes, we do have it. And let me check the namings again. Move right. Okay, it is correct. We will go to the vehicle example map, and we will just try the values out which we have done. Okay, this is actually great, but it is like it is not that smooth, like which I can feel. It is good though. Okay, this is one more issue which I can see when I am rotating my vehicle. Okay, so it's not that it is running fine, but see, it is sliding. Like if I want to show you, just give me a minute, I can simulate it, and see, it is sliding. Like like we can vehicle can go forward and backward, but it can't go left and right, correct? So, which is doing like the car is doing. So we will do some friction part too. Let's go head over to the IDE again. Okay, just to make the things little bit smoother, what we will actually do, we won't change the value directly. Rather, we will take some time and we will move from -1 to 1 slowly. So how we will achieve that? Okay, move right. So we will use math library u Kismet math library f interp. So what interp will do, it will slowly, like we will give the speed. So I do want to change the right axis value, and this is the target value which I want to change it to, and get world, get delta second, get delta seconds comma 5. So I am just giving it a speed. And let me cut paste it. Okay, so what it will do, it will try to, let's imagine my current axis value was 0 and suddenly I press the A button. So it will suddenly, like in the previous implementation, it will directly change from 0 to -1, which will be little jerky, correct? So what we are doing here, it will slowly, like it will take some time, like the real vehicle. So first thing is this, and another thing is we will add some frictions, like when we are moving left and right, correct? So just to have those calculations, so we have already calculated the local linear velocity, right? So what we will actually do, okay, so here we are like just go back to this line where we were adding just force for the forward direction, and we will add one more variable called f vector friction vector is so we will initialize at the f vector 0 vector, and if you Kismet math library, we will take the absolute local linear velocity y is greater than 2. Okay, so what I'm doing here, first I am checking the local linear velocity. Let's imagine I am facing the forward, so this is the forward direction of the vehicle. When it will move left and right, so this is the y axis, correct? That is why I am particularly checking for the white, and this is just the random value which I have gone through the R&D. Like even if it is moving by slight, I will start applying the friction. If it is 0, then I don't need to do that, correct? Okay, so what should I do? Friction vector is equals to body mass c get right vector into local linear velocity dot y into friction. Okay, we haven't set the friction constant yet, but we will, so and into -1. So friction const into -1. So what is friction const? So friction const is the friction value which will be constant throughout the game, and but we can tweak it. So just go back to the header file, and we will define, okay, we already have, do we, no, we don't have. So we will just define this, and I will keep this value to 500. So friction, okay, friction constant, copy paste friction constant. So what we are doing it here, uh, so this is the vehicle. If it is moving left, I want to apply the force in the right, so that is why I'm multiplying it -1. Friction constant is the value which I will like the magnitude which I'm taking, and this is the local linear velocity. The more linear velocity will be in the y axis, the more friction I will apply. So it is like that, and we will apply this friction vector in the forward one. So I will just add it here. So we are just adding forward vector and the friction. And friction force. Okay, and I will rename it as net force. Shift F6, net force. Okay, I have renamed it. Let's control B, or I think it should work fine. But I have made some changes in the header file, so I don't know if it will reflect those changes. Let's get back to the vehicle first, and let me check for the, okay, friction constant is here, so it has updated correctly. Let me check if it is working fine or not. Yes, it is a lot. See, now it is not that much sliding, but I'm able to control it. It is too smooth. Awesome. Now it is working like a car. Cool. It is drifting too. Okay. Cool. So this was it, I guess. It's already 16 minutes, so I will stop right here. In the next tutorial, we will see how we can add more functionality in our vehicle. So that was it. Please like and subscribe if you like my work. Thank you.